Hello, everybody. We're looking at lesson 28, the converse of the Pythagorean theorem. Okay, so the converse of the Pythagorean theorem is something that we can use. What the converse of the Pythagorean theorem is going to do is it basically uses Pythagorean theorem backwards. So normally we would use Pythagorean theorem because we know that there's a right angle. So we know it's a right triangle. So we use Pythagorean theorem to find a missing side. The converse of the Pythagorean theorem is where you know all the sides, but you don't know what kind of triangle it is. So you use Pythagorean theorem to see if it's a right triangle. And if it's not, then to see what kind of triangle it is. So we're going to look at this kite right here. This will be this kite right here. This will be what we use for the first example. So let's start with this. If you take the Pythagorean theorem and you write it as an if-then statement, let me change the view of this. If you write Pythagorean theorem as an if-then statement, it would say if a triangle is a right triangle, so if it's a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Or in other words, if it's a right triangle, a squared plus b squared equals c squared is going to work. They'll equal each other. Turn that backwards. It says if, so the converse of the theorem, which states if the square of the length of the longest side of a triangle equals the sum of the square of the two lengths, or in other words, if you set it up where c is the longest side and you do a squared plus b squared equals c squared, and if it works out, then what? Then it must be a right triangle. So the converse of Pythagorean theorem just goes backwards. So let's take this right here. Look at the sides you have. You have this kite thing right here. There's a 40-inch side, a 42-inch side, a 58-inch side. We don't know if it's a right triangle or not, but we think it could be. We think that this could be a right angle, this corner right here. How can you test to see if it is? So what we'll do, remember, Pythagorean theorem says that a squared plus b squared equals c squared. And what we have in this image is we have a kite. We have 40, 42, 58. Okay, well, I'm going to open this up, and you can kind of see the reflection right there. Probably right there. You see the reflection on my screen. I'm going to open this up on my screen here too so that I don't have to use the laptop the whole time. So just give me 1 second. Let me open this lesson up right here. Okay, so all right, this will make it easier for me to do this. Okay, so what we're doing here is we're just testing which one of those, if this is a right triangle, has to be C. C is always the longest side, so that would have to be C. So let's plug it in. If we do 40 squared plus 42 squared, does it equal 58 squared? That's what we're testing. We're not saying it does. We're wondering if it does. And think about it. If it does, what does that tell you? It tells you this is a right angle. If they don't equal each other, what does it tell you? It tells you that it's not a right triangle. It's still a triangle. It's something else. It's just not right. So if you look at they solve it for us right here in this example. So look at what they do. They set it up. They're not writing a squared plus b squared equals c squared, partly because we don't know for sure it works yet. So they're just doing side QR squared, see that, plus rs squared should equal qs squared, right here, qs squared. They plug in the 40, 42, and 58, 40, 42, 58. They then solve it, 1600, 1764, 3364. You add these together, you get 3364 equals 3364. So because they end up equaling each other, we have a right angle. Okay, so what if they don't equal each other? I want you to think about it like this. I'm going to show you just the basic equation, but I want to show you why it works. Okay, so if you have a perfect right triangle, you have C, A, B. If a squared plus b squared equals c squared, it's a right triangle. Okay, let's think about this. What about if you go to do it, but what happens is, let's take this, let's make c smaller. So if c is smaller, this is C, A, B. Is that a right angle now? You can tell. When you shrink down C, you can tell this angle is no longer a right angle. So if A squared plus B squared, if A squared plus B squared is greater than C squared, so we're saying when we add these together, the A and the B is bigger. Notice what I'm saying, because C got smaller. If C is smaller, is that a right angle? No. It's what do we call the angle smaller than right? We call it acute. And then let's make C bigger. So if we do this and we make C even bigger, now this has to open up like that. That's bigger than a right angle. So if A squared plus B squared ends up being less than C squared, then it's obtuse. Okay, you see that? That's why it works. Just imagine if C gets bigger, what does it do? If it gets smaller, what does it do? So that's the reasoning behind this last thing right here. Look right here. If C squared is equal to A squared plus B squared, it's a right triangle. If C squared is bigger, then it's obtuse. If C squared is smaller, then it's acute. All right? They flipped it from what I did, but the same idea, okay? So let's use these ideas right here. Let's use these concepts, and let's try to, basically we're going to take triangles, and without looking at them, we're going to use what we know about the sides to decide if they are right, acute, or obtuse. Okay, if three side lengths are 5, 12, and 13, what type of triangle is formed? So all we're going to do, we're just going to solve it. So I want you guys, why don't you try to go and do the first 5 questions. So press pause, and then do 1 through 5, and then press play. That's all you'll need to do to begin with. So press pause, do 1 through 5, press play. Okay, I'm hoping by now you've already tried these and pressed play. So let's do the first one. So for number 1, we're given the sides 5, 12, and 13. So just set it up. 5 squared plus 12 squared equals 13 squared. And then just take your calculator and we're just going to solve. That's all we're going to do. So 5 squared is 25. 12 squared is 144. And 13 squared is 169. So we have 25 plus 144. I'm going to stop doing this. I'm just going to write a little circle so you know that I don't know if it equals or not. I'm trying to decide. Equals 169. 25 plus 144 is 169. 169. And they equal each other. So if they equal each other, what kind of triangle do we have? We have a right triangle. So number 1, it's a right triangle. Number 2, it's 5, 12, and 15. So here's what I'm going to do. Hopefully this doesn't confuse you. It's 5 and 12. I'm going to leave all that there. I'm just going to leave that there, but I'm going to change this side of the equation. Now, hopefully some of you can just figure it out right away. Think about when it was 13, they equaled, and we're turning 13 into 15 over here. Can any of you we're taking the hypotenuse, making it longer. So just based on that, can you instantly tell what it is? Hopefully you can. If not, let's work it out. Go all the way through. 15 squared is 225. Add those together, 169. 225. What's bigger, the C squared or A and B squared? So it's 225 is bigger than the 169. What do you do when the C squared is bigger? That is obtuse. C squared is bigger, we have obtuse. And notice what we did. We took the length and we made the hypotenuse longer. Okay, now what we're going to do, we're going to go back to the original. Remember, 5, 12, and 13 worked. Now what we're doing, we're leaving it 5, 12, and 13, but we're taking the 5 and making it 6. So now the A squared and the B squared are going to be bigger if you compare it to the first one. Hold on. I'm sorry. Did I skip something? 5, 12, and 13, and then 5, 12, and 15. Oh, 5, 12, and 12. Okay, 5, 12, 12. So I think with 5, 12, and 12, you don't even need to, think about what's going to happen. We're just going to have 12 squared, 144, 144, right? 5, 12, and 12. So now 169 is bigger than 144. A squared and B squared are bigger, so what kind of triangle do you have? That would be acute. Okay, so that's number 3. Let's look at number 4. 6, 12, 13. So it's going to be 6 squared, which is 36. 36 plus 144. It's going to be 150, 180. And we're doing 6, 12, and we're doing 13. So over here we're going to have 13 squared, which is 169. What's bigger, 180 or 169? 180. So a squared and b squared are bigger. So if a squared and b squared are bigger, what kind of angle do we have? That's acute. So we just did 6, 12, and 13, and it's going to be acute. Last one, let's do 6, 12, and 15. Number 5. 6, 12, and 15. So I'm going to leave 6 and 12 there, and we're going to do 15. And 15 squared is 225. 225 is bigger than 180. So this one right now, the c squared is bigger. So if c squared is bigger, it is obtuse. All right. Now that you kind of have an idea, I want you then, we actually have a triangle with it. Don't just guess by looking at it. Don't look at that and go, oh, that looks acute. Never do geometry based on how it looks. Geometry is all about using math to decide things on shapes, not just looking. Your eyes can deceive you. There can be optical illusions. Or honestly, sometimes they can trick you and just draw a triangle and attribute different numbers. So these might not be drawn to scale, okay? So let's trust the numbers, not just how it looks. So I want you now to try to do 6, 7, and 8. And then you can watch me go over it, and then we will be done with this lesson. So 6, 7, 8. This one right here. So press pause, do 6, 7, 8, press play. Okay. Hopefully by now you've tried these 3, and now you can watch me go over it, make sure that you are right. Okay, so we're going to take this first triangle, and clearly the hypotenuse is the 73. So let's set up 48 squared plus 54 squared equals, or should equal 73 squared. So it's going to be 48 squared plus 54 squared is what relationship to 73 squared? I'm not about to do these in my head, so I'll pull up the calculator. So let's do 48 squared, 2304, plus 54 squared, 2916, and then 73 squared, and it's 5329. Okay, and then let's add 2304. So we do 2304 plus 2916, and those equal 5220 compared to 5329. The 5329 is bigger, so c squared is bigger. So when c squared is bigger, what kind of triangle do you have? You have obtuse. I think if you just go based on eyes, you'd be tricked and think, oh, this looks like a right angle. Yeah, it looks like it's 90 degrees, but it might be 91 degrees, which would look like 90. But when we actually crunch the numbers, we realize, oh, this is slightly bigger than a right angle. It's obtuse. Number 7. Remember, you go based on the biggest side is where you would put the c squared. So on this one, the biggest side is the 25. So we're going to have 20, let's do 10 squared plus 24 squared equals 25 squared. All right. So 10 squared is 100. 24 squared is 576. 25 squared is 625. Add those together, you'll get 676. 676 is greater than 625, so my a squared and b squared are winning. So when a squared and b squared are better, that's going to be a cube. Oh, I'm sorry, I'm messing up. This is just, is it right or is it a right triangle? Yes or no? So I'm doing too much work thinking about acute and obtuse. What I should do in this case is just look at those, and instead of writing, I'll just say it does not equal each other. If it's not equal, we don't care about acute obtuse. We're just saying, no, it's not right. Is this a right triangle? 63, 16, 65. Okay, so 63 squared plus 16 squared. And how does that relate to 65 squared? Okay, so 63 squared, 3969, plus 16 squared, 256, and then 65 squared, 4225. Okay, add up 3969 plus 256, and we get 4225. 4225 certainly equals 4225. So is it a right triangle? Yes, it is a right triangle. All right, that is it. If you have any questions, as always, shoot me an email, and I hope you guys have a great rest of your day.